Hello, everybody. Hope you are doing good. Let us talk about refractive index. What refractive index is? When we are talking about refractive index, we need to know, first of all, refraction. So, refraction is actually when a ray of light or a wave passes through one medium to another medium, it's bent from its original path. So you can say bending of light from its original path, bending of light from its original path when it enters from one medium to another. Okay, the problem here is why light bend? It's because of a physical quantity. We now name it as refractive index. What is refractive index? Refractive index is denoted by letter small n in physics, and it is the ratio of speed of light, in vacuum to the speed of light in that medium, to whom we are finding the refractive index. For example, if I would like to say that we have glass here and we are trying to pass the light from air to the glass. For example, this is a glass slab. What actually happens is when this light ray is coming from the air, so this is speed of light that we usually represent by c, that is 3 into 10 to the power 8 meter per second. When it get into the glass from air to the glass, what happened? It should go straight, but rather to go straight, if you draw a normal line here, so you will see that this line, rather to go straight, will bend a little bit toward the normal. This happens because the speed of light reduces in the glass. For example, the speed of light in air is 3 into 10 to the power 8. And in, for example, glass, this speed of light is 2 into 10 to the power 8 meter per second. So what we will say, the refractive index of the glass will be equal to speed of light in vacuum, or you can say air, to speed of light in glass. When you will divide these two, what you will get? You will get the refractive index of glass is equal to 3 into 10 to the power 8 meter per second to 2 into 10 to the power 8 meter per second. That gives us that refractive index of glass is equal to 1.5. And there is one more thing that we need to remember, that the speed of light over the speed of light in two different mediums uh, is same thing divided. So meter per second cancel by meter per second. So refractive index n does not have any unit. So you will not need to write any unit for the refractive index. Okay, similarly, if we have this one, speed of light in one medium to another medium is called refractive index. So we have many other mediums, like uh, in the water, we know that speed of light to the air into water, when we use this, the refractive index of the water is approximately 1.33. Refractive index of the diamond is equal to 2.42, but refractive index of the air, that is considered as the vacuum, so we can say 1.00. Whereas the glass, we have different types of glass, so it ranges from 1.5 till 1.6. So these changes on the dependent of the different. No, quite the important point comes in our mind when we want to know uh, the refractive index. So due to change in refractive index, what happened is, whenever a light ray passing through one medium to another medium, it enters to the other medium, it changes its path. For example, if this is the ray of light entering from air to the glass, so it will change its path, and rather to go straight, it will bend around, and then when it enters from glass to air, it will bend away from the normal. So this thing says that whenever you have a ray of light coming, so this is, for example, incident ray. So this incident ray making an angle theta, let's say theta 1, to the normal. This is the red line that I am showing is normal. So this angle is refracted angle, that is theta 2. So it is very obvious that theta 1 will be lesser than theta 2 when light enters from air to the glass. But on the other hand, when the light ray enters from glass to this, so theta 3 will be smaller than theta 4. So it will bend away. So this refracted ray will bend away whenever it goes from high refractive index medium, because glass has refractive index greater than the air. So air refractive index, let's say N1, glass refractive index, let's say N2. So we have to remember that whenever light enters from air to glass, low refractive index to high refractive index, so it will bend toward, so angle inside the high refractive index medium will be shorter. So we can simply say that in first ray when it incident, so refractive index theta 2 was small, but when it get back to the air from the glass, so its theta 3 was the smaller. So you can say theta 3, this theta 3 is smaller than theta 4. But in the first one, theta 1 is greater than, by mistake, I wrote it less than. So we can just simply say that always angle made by incident or refracted ray with the normal, refracted ray with normal is always smaller. Normal is smaller in high refractive index medium. High refractive index medium. So whenever you can say the glass is high refractive index, so angle either incident or refracted, which is inside the glass, it will be smaller. Similarly, this thing, when we further go through, we can say that light ray that bends toward or bend away from the normal depending upon the refractive index was explained by a scientist called Snell. So Snell's law says that if you have a ratio of refractive index into sine of the angle, it is always constant. So if I say in this case, the figure shown, so refractive index of the air with the sine of the incident angle, let's say theta 1, will be equal to refractive index of the glass into sine of the angle incident refracted inside the glass theta 2. But if you want to write the same equation in the form of when it was passing from glass to air, so you can write it as n of the glass times sine theta 3 will be equal to refractive index of the air into sine of the refracted angle theta 4. So you can simply, or generally we can just say that whenever we talk about two different media, so you can simply say n1 sine theta 1 will be equal to n2 sine theta 2. For example, I just say that if the air from air to the water, for example, ray of light is entering from air to the water. So air refractive index, you know that 1.0, and water refractive index is 1.33. So if the incident angle is given to you is, for example, 45 degree, the refractive index for sure will be less than 45 degree. So if you want to find that theta 2, so you will use simply n1 sine theta 1 is equal to n2 sine theta 2, and this way you can just simply find theta 2 by n1 sine theta 1 over n2 is equal to sine theta 2, or simply you can say theta 2 is equal to sine inverse n1 is refractive index 1 times sine 45 divided by refractive index of the water 1.33. You can use the calculator and you can get the value. So this is how we can talk about the refractive index. We can calculate the speed of light. Like for example, if you are asked to find speed of light in diamond, so you can say by using the refractive index of the diamond is equal to speed of light in air over speed of light in diamond. So you can simply say speed of light in diamond V in D is 3 into 10 to the power 8 over this. So you can just simply write 3 into 10 to the power 8 meter per second over refractive index of the diamond is 2.42. So you will find the speed of light in the diamond, similarly in the water, in the glass. So everywhere you can find. Hope you guys understood this one, and thank you so much if you got understanding, and if you have any issue, so you can just repeat the video, you will have complete understanding. Thank you so much.